Ever look up at the night sky and feel small? It's a common experience, one that has fascinated humans for millennia. The vast expanse above us, dotted with countless stars, planets, and galaxies, can make anyone feel insignificant. You should. The universe is vast, filled with more stars than grains of sand on all the beaches on Earth. Imagine that for a moment. Every single grain of sand on every beach, and there are still more stars out there. It's a humbling thought, isn't it? Wrap your mind around that for a second. It's almost impossible, right? The sheer number of stars is beyond our comprehension, and each of those stars could have its own system of planets, potentially harboring life. The possibilities are endless. Now imagine shrinking our sun, a fairly average star, down to the size of a grapefruit. This helps us grasp the scale of things a bit better. The sun, which is massive and powerful, reduced to something we can hold in our hand. On that scale, Earth would be a tiny dot, barely visible to the naked eye. Our entire planet, with all its mountains, oceans, and life, reduced to a minuscule speck. It's a perspective that can change how we see our place in the universe. The nearest star? A whole other grapefruit, but over 2,000 miles away. That's like having one grapefruit in New York and the other in Los Angeles. The distances in space are truly mind-boggling. This immense scale is part of what makes stars so fascinating. They are not just points of light in the sky, they are colossal entities separated by vast distances. Each star has its own story, its own journey through the cosmos. They're giant balls of burning gas, millions of miles across. Yet from our vantage point, they twinkle like tiny diamonds scattered across a velvet cloth. This contrast between their true nature and how we perceive them adds to their mystery and allure. It's enough to make you question everything you thought you knew about the universe. How can something so vast and powerful appear so delicate and beautiful from our perspective? It challenges our understanding and ignites our curiosity, but this sense of wonder is just the beginning. The more we learn about the universe, the more questions we have. Each discovery leads to new mysteries, new frontiers to explore. It's a never-ending journey of exploration and understanding. Let's dive deeper, shall we? There's so much more to uncover, so many more wonders to behold. The universe is vast, and our journey through it is just beginning. Join us as we explore the cosmos and seek to understand our place within it. Stars aren't just scattered randomly across the universe, they're born in vast clouds of gas and dust called nebulae. Picture a cosmic cloud darker than the darkest night, swirling with the raw ingredients of creation. Gravity is the master sculptor here. It slowly draws these particles together, squeezing them tighter and tighter. As the cloud collapses, it heats up, eventually reaching temperatures so extreme that hydrogen atoms fuse together, forming helium and releasing a tremendous amount of energy. Boom! A star is born. These stellar nurseries are some of the most beautiful and awe-inspiring sights in the cosmos. They glow with an ethereal light, illuminating the surrounding space with vibrant colors and intricate patterns. Hubble telescope images of these nebulae are enough to make anyone believe in the magic of the universe. When we think of stars, we often picture them as white, twinkling dots, scattered across the night sky like tiny diamonds. This image, while beautiful, is just a small part of the story. But stars come in a kaleidoscope of colors, each hue a clue to its temperature and age. From the fiery blues to the cool reds, the color of a star can tell us so much about its life and the processes happening within it. Hotter stars blaze with a fierce blue light, burning through their fuel at an incredible rate. These blue stars are often young and massive, living fast and dying young in cosmic terms. Their intense heat and energy make them some of the most fascinating objects to study in the universe. Cooler stars emit a gentle red glow, their energy reserves lasting for billions of years. These red stars, often smaller and older, are like the wise elders of the cosmos, having witnessed the birth and death of countless other stars around them. Our sun, a middle-aged star, shines with a warm yellow light, a beacon of life in our solar system. It provides the perfect conditions for life on Earth, balancing its energy output to sustain our planet's delicate ecosystems. And then there are the giants and supergiants, stars so massive they dwarf our sun. These colossal stars can be hundreds of times larger and thousands of times more luminous, dominating their regions of space with their sheer size and brightness. These behemoths can be red, orange, or even blue, their immense size making them some of the most luminous objects in the universe. Their life cycles are dramatic, often ending in spectacular supernovae that seed the cosmos with heavy elements, essential for the formation of planets and life. So, the next time you gaze up at the night sky, remember, those twinkling points of light aren't just white. Each star is a vibrant hue, a testament to the diversity and complexity of the universe. They're a rainbow of colors, each telling a unique story of cosmic creation and evolution. From their birth in stellar nurseries to their eventual demise, stars are the storytellers of the universe, each one a chapter in the grand cosmic narrative. Section 4. Starlight, Starbright, the language of the cosmos. Light from distant stars takes thousands, even millions of years to reach our eyes. So when we look up at the night sky, we're actually peering back in time, witnessing light that originated when dinosaurs roamed the Earth or even before life began. But starlight is more than just a time machine. Astronomers can analyze the light from stars, breaking it down into its component colors, like a cosmic barcode. This process, called spectroscopy, reveals a wealth of information about a star's composition, temperature, and even its movement. It's through starlight that we've discovered what stars are made of, how they evolve, and even the expansion of the universe itself. It's a language written across the cosmos, and we're just beginning to decipher its secrets. Section 5. Heavy metal fans, forged in the heart of a star. Ever wondered where the carbon in your body came from? Or the gold in your jewelry? Look no further than the stars. The elements that make up everything we see and touch, even ourselves, were forged in the fiery hearts of stars billions of years ago. The intense heat and pressure deep inside stars act like giant cosmic furnaces, fusing lighter elements into heavier ones. When massive stars die in spectacular supernova explosions, they scatter these newly formed elements into space, seeding the universe with the building blocks of planets, life, and even you and me. So, the next time you hold a piece of gold or admire a diamond, remember, you're holding a piece of stardust, a relic of a long-dead star. Pretty cool, right? Section 6. Stellar life cycles from birth to spectacular deaths. Stars may seem eternal, but they have lifespans too, some longer, some shorter, just like us. These celestial bodies are born, live out their lives, and eventually die, each in their own unique way. The journey of a star from its birth in a nebula to its eventual death is a fascinating process that spans millions to billions of years. A star's life cycle is a delicate dance between gravity, which tries to compress it, and nuclear fusion, which tries to blow it apart. This balance determines the star's size, brightness, and lifespan. The story begins in a nebula, a vast cloud of gas and dust. Over time, gravity pulls the material together, forming a protostar. As the core temperature rises, nuclear fusion ignites, and a star is born. Smaller stars like our Sun live for billions of years, slowly fusing hydrogen into helium. These stars are relatively stable, spending the majority of their lives in a phase known as the main sequence. During this time, they shine steadily, providing light and warmth to any surrounding planets. Our Sun, for example, has been in the main sequence for about 4.6 billion years, and is expected to remain there for another 5 billion years. Eventually they run out of fuel and expand into red giants engulfing nearby planets. As the hydrogen in the core is exhausted, the core contracts and heats up, causing the outer layers to expand. This transformation marks the beginning of the end for the star. In the case of our Sun, it will expand to such an extent that it will likely engulf the inner planets, including Earth. Finally, they shed their outer layers, leaving behind a dense core called a white dwarf, which slowly cools over billions of years. This remnant is incredibly dense, with a mass comparable to the Sun but a volume similar to Earth. Over time, the white dwarf will cool and fade, eventually becoming a cold, dark, and inert object known as a black dwarf, though the universe is not old enough for any black dwarfs to exist yet. Massive stars, on the other hand, live fast and die young. These stars are much larger and hotter than their smaller counterparts, burning through their nuclear fuel at a much faster rate. As a result, their lifespans are measured in millions rather than billions of years. Despite their short lives, massive stars play a crucial role in the evolution of galaxies. They burn through their fuel quickly, ending their lives in spectacular supernova explosions, briefly outshining entire galaxies. When a massive star exhausts its nuclear fuel, its core collapses under gravity, leading to a catastrophic explosion. This supernova can outshine an entire galaxy for a short period, releasing more energy in a few seconds than our sun will emit in its entire lifetime. These explosions are the most powerful events in the universe, shaping galaxies and seeding the cosmos with heavy elements. The remnants of the supernova, including elements like iron, gold, and uranium, are scattered across space, eventually becoming part of new stars, planets, and even life itself. Thus, the death of a star is not an end, but a new beginning, contributing to the ongoing cycle of cosmic evolution.